and then you have your transfer RNA come in with your methionine.
So was methionine already attached to the transfer RNA?
Yeah, because that is part of the.
It was already attached to the
This is the code.
And,
I'm just attaching because I don't want to have to read.
No, I totally understand. So it was already attached. I just like to ask questions in one. Is that cool? Okay, so you're just doing a good job. And so anyway, so it comes in, and is it coming in at the same time that the 60S is coming in, or are they like sequential?
The 40 or the
60S.
The 60S comes in,
and
then
first, or does it come in at the same time that one's coming in?
Same time.
Same time.
All right.
So it turns out that at the same time your anti-codon is going to match up to the codon. Show me that. That's going to be cool.
So one second. So then, start over. Okay. So the 40S comes, and then the 60S comes right afterwards, because the 60S does not come until the 40S binds.
Yeah, and get this. You actually, the 40S comes first.
Right.
Then you get your transfer RNA coming in. Watch. No, not even with it. It's coming in. Watch. That's coming in. Okay, now I got the 60S. That's coming in. Go ahead and make it come in and bind. And I'm slipping it underneath you at the same time. You with me?
Gotcha.
Okay.
All right, fine.
It all happens at the same time.
So then.
You got that on video? Nice, huh?
So one sec. Which I don't know which code that goes, but then.
Okay, now well, it leaves the A site open. It looks like.
So and then we.
So it went on the P site right away.
Right.
With the first one.
Right. And
Sorry.
then we have. Check. And then we have this. The C comes in with the GA, and I believe it's.
And the anticodon matches the codon.
Correct.
And that was alanine, right?
It's alanine, yeah.
It's it was argued.
Yeah.
Well, that's what the code was on the thing.
Is it supposed to be alanine?
See, I think here's what you did. Watch. Check this out. If I take the codon, which is GCU, right? So I got G and C and U. It's alanine. You took the anticodon, CGA. Watch. CGA codes for arginine. Okay. Don't ever do that. You never read the anticodon.
Pretend alanine.
No, we're gonna write it in right now. Let's do it. Yeah. So ALA. Yeah.
So we take it from the mRNA.
Yeah, always, because that's the codon.
Right.
The anticodon is not what you read when you're using a genetic code like that. You read the codon.
So, all right, so then this comes, and then it forms and then it forms a covalent bond or a peptide.
Cool. Oh, wow. Attached to the 60S subunit. Where is the enzyme? It's attached to the 60S subunit. So it's part of the 60S subunit. That's why you need the P and the A sites, because the enzyme sits right in between the P and the A sites. You understand? So when you get one on the P, one on the A, then you get your, you're right on. It turns out right underneath these two amino acids is peptidyltransferase. Perfect. Perfect position. You land right on the enzyme. Enzymes have certain shapes that fit the two, substrates that you're trying to put together. So what happens is now it fits these two guys. You get the peptide bond between methionine and alanine. So where's the tape? I want to see that tape. I want to see that tape. Take the tape. Take the thigh. And I'm going to peptide bond it right here. See that? Wasn't it? Yeah. You like my technique? Right. You got it on tape, right? Nice. And then this shifts. This shifts to the next site. So yeah, so the same time you made that peptide bond. And this is all pushing. Yeah, it's hard. Right. That's what I'm talking about.
And then this comes off.
Okay, so this transfer RNA then leaves because it's no longer on the P side. And the second transfer RNA is on the P side. And it goes out the cytoplasm? Yeah. Does it get destroyed?
No, it looks for more amino acids. The same.
Which amino acid?
Methionine.
Methionine, yeah.
Methionine.
So met. Yeah, methionine.
It goes and looks again for it.
Yeah, so it could use it again, like in making a different polypeptide somewhere down the line, or maybe in the same one if you have another AUG. Is that right? You guys are awesome.
So then we have, now it comes back to this bonds to the A site with I believe it's the valine.
Yeah, what was the next one? Let's look real quick. So GCU and then CAA. What's CAA? C and then A and then A is glutamine. So GLN. Glutamine.
Oh, there we go.
There we go. Okay. And so we have that, and then So and then the peptide
Bond
enzyme-
occurs? Oh, watch this. So the peptide bond occurs. Oh yeah, you're amazing. Okay, put tape on that. I want to see the tape. Yeah, look at that. You see, he makes a better peptide bond than I do.
No, I attach it to the
Yeah, I guess
thing
it wasn't as good
underneath.
as mine.
There we go. We're
There,
good.
it's,
Now
it's
it's
beautiful.
yeah, it is. It's not bad at all. It's kind of a little wrinkle.
All right, and then this again shifts while staying there, and then this also, and then this comes back and goes back into the cytoplasm looking
gets
for
another?
glutamic acid.
No.
Glutamine.
No.
What?
Oh, this was the alanine.
Yes. Good job.
The alanine,
Alan.
sorry.
Yeah.
And then this attaches over here with
What
the
was CUU? What did that go for?
Valine.
Just make sure we got the right one. CUU was leucine. Leucine. LU. Sorry, you guys.
It's okay.
I'm kind of a perfectionist on these things.
So then we have this,
Okay.
and then this were to shift also
Uh-huh.
over to here.
And,
And
I
then
want
we
to see
have
that
the
peptide bond. Wait, I want to see the peptide bond.
peptide bond.
So get the tape.
Peptide bond,
Good
right?
job.
And then it shifts, and then this goes back into the cytoplasm,
Picks up another.
picks up another
Glutamine, yes.
Glutamine, yeah.
glutamine.
Glutamine,
And
yeah.
then here we have our stop codon,
Okay, so what attaches to the stop codon in this area?
the
Release
releasing
factor.
factor.
Releasing factor, so it comes in, so releasing factor comes in.
That's
Look
why I
at that.
turned it upside down.
Yeah, that's nice.
You
Oh,
ruined-
you turned.
you
I'm
ruined
sorry, I'm sorry. I did, I'm sorry. Yeah, I messed up.
and then this goes back into the cytoplasm, and now we're left with our polypeptide.
And do these break apart also?
Yeah.
Yeah.
And messenger RNA, what if this, you only needed one of these? What would you do with the messenger RNA? Destroy it. If you needed 10 of them, then these guys can come back and start all over again, can't they?
Yes.
Yeah, nice.
And
Or
that-
another one.
And that is
Yeah,
protein
10 more
synthesis.
times. And look, you have a thank you, Yehuda. You have a sequence of amino acids, and they're leucine, or I'm sorry, methionine, then alanine, then glutamine, and then leucine. Do you see that? Now, is that sequence really important?
Yes.
That's why you did all that.
What was this called?
That's a polypeptide.